Okay. Hello everyone, welcome to the OneClass channel. My name is Andrew and I'm a university student doing statistics and mathematics at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, check out the links in the description below. So let's jump into our first question today. All right. Okay. So our first question is asking us, I'll write it down here. What is antiderivative? Derivative. All right. So first, antiderivative has also another name, which is an indefinite integral, and it is usually defined to be the reverse of the derivative of a function. And in the graph of the function, the antiderivative represents the area under the curve which following specific boundaries. And the formula for the antiderivative is already on here. Fx derivative fx dx where c already here. C is the constant. Okay. And also, known as indefinite integral of a function. And it is the reverse of the derivative of a function. And if we want to represent that on a graph, the antiderivative represents the area under the curve. So area under the curve. Right. So let's use an example to go a little bit deeper. So for say we got a derivative of x squared, and in this case the derivative of f squared, we just move 2 to the front and -1 for the exponent part, so we have 2x, and the antiderivative of 2x, it will be x squared plus c, where c is a constant. So right here it's integral, or we say the antiderivative of 2x is x squared plus c, where c is the constant. So we're just doing this by the reverse way of doing a derivative. Okay, so let's use another example. Let's say we want the antiderivative of 3x squared. So by the formula we have given earlier, it will be equal to 3x squared dx 3 times 1 over 2 plus 1 times x to the exponent of 2 plus 1, which is equal to 3 times 1 over 3 x to the exponent of 3. And then this is also equal to x to the exponent of 3, because 3 times 1 over 3 is just 1. So our capital Fx is going to be x to the exponent of 3. And so in the graph of function, the derivative of the function is the slope of the tangent at a certain point in the function, while the antiderivative represents the area under the curve with specific boundaries. So something like this. Oh, should be a plus c. So that's the y-axis, x-axis 0. See, we got a function y is equal to fx, and that's a b are our two boundaries, and that's our area A. So in this graph, the derivative of a function is the slope of the tangent at a certain point in the function, while the antiderivative represents the area under the curve. So will be this part, the yellow part. Yeah, with specific boundaries. When this where in this case would be A and B. All right. So I think that's all we got for this question. Good job. Okay. So now let's move to our second question. Oops. Okay. So for this one, it's asking us what is a quotient rule. Second. Is the quotient. So first, let's write the formula down for quotient rule. So whenever we need to take the derivative of a function over a function, it's going to be equal to gx times the derivative of x minus fx times the derivative of gx over gx to the exponent of 2. Right. And so the quotient rule apply when we need to take the derivative for the quotient of two functions. Right. And about is our formula. And the quotient rule, we usually, okay, I'll use an example to explain. So first, let's say we have a fx is equal to 2x plus 8, and we got a gx is equal to 1 minus x. And now we want to find out the derivative of fx over gx. So first, I'll write down the steps to solve these questions. Okay. So first we need to multiply the denominator function by the derivative of the numerator function. Right. And then we need to multiply the numerator function by the derivative of the denominator function. Which corresponding to gx derivative of fx, fx times derivative of gx we had earlier. And then after multiplying these two, we'll need to subtract the answer in step 2 from the answer in step 1. So that's 1, 2, 3. All right. So after we done the subtracting, our last step will be we need to divide the answer from step 3 by the square of the denominator function. Which corresponding to our gx squared we had earlier. All right. So now let's copy down the fx gx. So now we have our fx equal to 2x plus 8 and gx is equal to 1 minus x. So our step 1, following what we have about, step 1, we need to multiply the function in the denominator by the derivative of the function in the numerator. All right. So that's going to be gx times the derivative of fx, which is going to be equal to 1 minus x, which is gx, times derivative of fx. Yeah. So this part is our gx, and this part is our derivative of fx. Right. So maintain 1 minus x the same. We just need to take the derivative of 2x plus 8, which is just going to be 2. So the answer for gx times the derivative of fx is going to be 2 minus 2x. Yep. So that's all we have for step 1. And for step 2, we need to multiply the function in the numerator by the derivative of the function in the denominator. So it's going to be fx times the derivative of gx. So we have 2x plus 8 times derivative of 1 minus x. So this part is fx, and this part is derivative of gx. So 2x plus 8 times derivative of 1 minus x is just going to be negative 1. So our answer will be negative 2x minus 8. Great. So following the third step, we need to subtract the answer in step 2 from the answer in step 1, which are these two. Great. So it's going to be gx derivative of fx minus fx times derivative of gx, which is 2 minus 2x minus negative 2x minus 8, which is equal to 10 after the calculation. Right. So our final step, we need to divide the answer from step 3. Divide the answer from step 3 by the square of the denominator function. Okay. So let's copy down the formula first. Gx derivative of fx minus fx times derivatives of gx divided by gx to the exponent of 2, which is going to be 10, because this 10 is what we have for the numerator, over gx squared, which is going to be 1 minus x squared. Okay. So we can write our conclusion. Therefore, the antiderivative of the quotient of the functions fx equal to 2x plus 8, gx equal to 1 minus x, after applying the quotient rule, is 10 over 1 minus x squared. Yep. Yeah, I think so. That's the end for our example. So just make sure that, don't forget, when you're dividing at step 4, don't forget it is a square of the denominator function. And don't forget it's subtracting on the third step. Yeah. So just pretty much multiplication, subtracting, and dividing. Yeah, I think that's all we have for this question. Okay. Work well done. Okay. All right. So coming up, we have our next question. So it's asking, what is the derivative of cosine 2x? Okay. So now, just for easy for showing the steps, we'll let y is equal to cosine 2x. Okay, and in order to find the derivative of the given function, we'll let u is equal to 2x. So our derivative becomes to dy dx is equal to d derivative of cosine u, and apply the chain rule right on the side. Chain rule apply. We'll have dy over dx is equal to dy over du times du over dx. Right. So the derivative of the function will be derivative of cosine u is equal to derivative cosine u times du dx, which is going to be negative sine u times du dx. So now, since we substitute 2x by u, so now we need to substitute back. I'll write it on here. Substituting back the value of u is equal to 2x about we have derivative of cosine 2x is equal to negative sine 2x times derivative of 2x. Right. And we know the derivative of 2x is just going to be 2. So this is equal to negative sine 2x times 2. And we take 2 to the front, so it comes to negative 2 sine 2x. So, in our conclusion, we can say hence the derivative of cosine 2x is negative sine 2x, right? So, a couple things I want to highlight in this question is, first we need to apply the we need to do this by substituting u, sub u, and also don't forget to substituting back the value, because we only want the variables at our final answer instead of u. And and don't forget, when you take the derivative of cosine u, it's going to be negative sine u. So don't forget the negative sign. Yeah, I think that's all we have for this question. Negative 2 sine. Right. Okay. So next question. We need to classify the triangle. Check all the apply. All right. So here's the triangle. and they have the same length of side, same degree of angles. Okay. Okay, so let's write down the choice. So the first one is equilateral. Second one will be right. Third one will be obtuse. D is acute. B is scaling. And F is S. Alright. So first, let's define. Let's go through each. So from the figure, we can see that all three sides of the triangle have the same length, and all three of its angles are equal. So first, it follows the rules of equilateral. Okay, so check A. And for B, right triangle. So whenever we have a 90 degree, we will consider that as a right triangle. So for here, since we know the interior angle for triangle is 180, and we say the, let's call this ABC, we know A is equal to B is equal to C, which means also we know that A plus B plus C will add up to 180. So A is equal to B is equal to C is equal to 60 degrees, because 3 times 60 is 180. So there, it is not a right triangle. So things is greater than 0 degree and less than 90 degrees. So is this triangle is also an acute angle. Acute. And because there's no angles over 90, so it's not going to be obtuse. Okay, and yeah, so we can also consider this triangle as an isosceles triangle because at least two of its sides have equal length. So that's going to be F. Right. So another example of F would be something like this. Yeah, as long as it has two of its sides have this equal length. Yeah. So for E, it just means all three sides have different length, which is not possible in our case. So our answer would be